All right, guys, today we're going to be talking about cold fronts and warm fronts. Now, when we see a weather map, and I'll just use this as an example, we're going to see this one a little bit later on. We see a bunch of blue lines with triangles on it. We see some red lines with some half circles on it. We see some lines that have both the red and the blue. And sometimes, not on this map, but sometimes we'll actually see purple uh, lines. And so today we're going to be talking about what these lines represent. So these lines represent what we call fronts. And a front in weather is the movement of one type of air into an area that has a different type of air. And so when I say type of air, I'm talking about basically the temperature. So, for example, um, if it's 80 degrees in San Antonio today, we may have a cold front that blows through, creates a couple of storms, and then the next day it's down in the 70s. So what that means is that an air mass of colder air moved into the area and kind of pushed the warm air out of the way, and the cold air came in and took its place. So it's important when we are predicting the weather to understand what these lines represent, what direction these fronts are moving, because it goes a long way to understanding what the future weather will be. So again, we'll talk about this map in a little bit more detail here in a second. But first of all, let's just talk about the difference between the two types of fronts. So we have cold air, cold fronts. Okay, usually they're indicated by this blue line with the blue triangles on it, and the triangles always point in the direction that the air is moving. So cold front represents the border between the cold air and the warm air, and the cold air is moving into an area. And so because cold air is more dense, it tends to sink towards the surface of the earth. And as it moves into an area, it forces the warm air up. And that warm air, whatever water vapor that warm air is carrying, when it gets forced up in the atmosphere to cooler temperatures, uh, that water vapor then condenses into clouds and basically creates thunderstorms. So as you see in the picture down here, as the cold air is advancing into this area, it forces the warm air up, which creates this uplift of water vapor turning into clouds, which creates thunderstorms. So normally when a cold front moves into an area, that creates thunderstorms. So the storm that we got the other night in the middle of the night was literally because of a cold front moving through the area. Now, when we say cold front and warm front, we're just talking about a significant difference in temperature, but it doesn't necessarily mean a cold front doesn't necessarily mean it's going to be freezing air. It just means colder than the air that's in place. So if it's 90 degrees on Monday and a cold front moves through, that cold front may drop the temperature to 80, which is still warm, but the air is colder than the air that was in place. So what you need to really understand is as this cold front moves through an area, it usually will create pretty heavy thunderstorms. Okay. So again, a cold front is indicated on a weather map with a blue line with triangles. You'll notice here we've got the temperature here in Brownsville, Harlingen, and Raymondsville in the 80s, 89 and 87. Behind the front, you can see that the temperatures have drastically decreased into the 50s and 60s. Okay, so you can predict, because these triangles are pointed to the south, that in the future for Brownsville, Harlingen, and Raymondsville, that it's going to get colder. So when you see a map and you look at the front, you can make some predictions about the weather on both sides of the front. Okay. So again, cold air moving into an area, forcing the warm air up. and the cold air replacing that warm air. Now, the warm front is, literally just the opposite, where you've got cold air in place and the warm air is moving in. But the difference is that warm air doesn't dive underneath the cold air. The warm air just kind of rides over top of the cold air, pushing the cold air out of the way. This still creates clouds. It can create some rain, but usually the rain in a warm front is usually like drizzle or small showers, but nothing significantly major like we had the other night. With the thunderstorms and the lightning and the wind. So it's usually a more gentle change in the weather, but there is still a significant change in the weather. Okay. So again, warm air is always going to ride over top of cold air because of its density. Cold air is more dense, so it sinks. Warm air is less dense, so it rises. And again, the half circles that you see on a weather map point in the direction that the front is moving. So normally you'll see the cold front arrows pointing south because that cold air usually is coming from up north, Canada, the Arctic, and so forth, and moving towards the south. And you'll normally see warm fronts normally coming from the south heading to the north because that's where the equator is, the warm, moist air from the Gulf of Mexico and the Caribbean moving up into the continent. So normally, there are some exceptions, but normally you will see cold fronts typically moving from north to south, and you'll see warm fronts typically moving from south to the north. So you can see in this picture up here, it's 0 degrees in Minneapolis, 25 in Des Moines, 29 in Omaha. And you can see below this in Kansas City, Wichita, Kansas, or Dodge City, Springfield, that the weather is warmer. Now, it's still cool, for us, especially here in San Antonio. 44 and 49 is still pretty cool. But relative to the air that it's getting ready to replace, it is warmer. So this would be considered a warm front moving northward into Iowa, Minnesota, Wisconsin, and northern Illinois. Okay. So these are the different symbols that you'll see on a weather map. Of course, again, the blue line with the blue triangles represents a cold front. The cold air is behind the triangles. The triangles always point in the direction that the front is moving. Warm front is a red line with red half circles. Again, the warm air is behind the half circles, and the half circles are showing the direction of movement. There's also such a thing as an occluded front, which brings really super severe weather. Normally we see tornadoes associated with occluded fronts, and that's when a cold front and a warm front are moving side by side. So you've got one moving down and one moving up, and they kind of hit each other on the edges and create this rotational movement like we talked about on Tuesday, which can create some very severe storms. And then we have stationary fronts, and that's usually when a cold air mass is moving south, a warm air mass is moving north, and they meet. And neither one of them has the energy to kind of push the other one out of the way. And so they become just a stationary front that sits over an area for a day or two with no movement either way. And so again, you'll have sustained rain, sustained bad weather, but not severe weather with stationary fronts. So the next 3 slides show you basically the next 3 days of weather. So this is the National Oceanic and Atmospheric Administration's weather map for Wednesday, March 24th, which is the day I'm recording this. And they say it's good until tomorrow, Thursday, which will be probably the day that you watch this. So you'll notice if we just look around the map, we can identify where the cold, warm fronts are. You can see here we've got warm air kind of moving this direction. We've got cold air moving towards the south, another cold front here, another cold front here as well, mixing with some warm air coming up. So this would be like an occluded front right here. You can kind of see a little hook. This would be a stationary front that you see here in the Gulf of Mexico. So we've got warm air from the Gulf trying to move north. We've got that cool air probably associated with the storm that we had the other night trying to move south. And so this has created this stationary front right here in the Gulf of Mexico, and also over here. Now, the different shadings of the green, yellow, purple, it gives you a key right here. Also, remember we identified where H's, high pressure and low pressure, and how they are associated with the types of weather. But you can see here that the majority of the United States, up here in the Pacific Northwest, the Midwest, over into the East Coast, is under some threat of a lot of weather. So we've got some rain here. We've got rain and thunderstorms here where you see these checks. We've got this yellow stripes, which is severe thunderstorms possible in the Ark-La-Tex area. Snow still in some of the areas, mixed precipitation, which means it could be some rain, some snow. Heavy snow possible here in New Mexico, in the mountains as well. But what we can do now is predict. So if we look at this cold front here, let's just focus in on this one. We can see that the arrows are pointing towards the east. So if we look at the next day map, we would expect this blue line to be further to the east. And so while some of that moved a little to the east, the warm air has come into play here and kind of pushing up against that cold front there. So this would be from Thursday to Friday. So this is the weather prediction from Thursday to Friday. So you can see here in San Antonio, we're still kind of in the area of rain and thunderstorms. You've got severe thunderstorms possible all the way through the southeast. And then again, you can see this cold front right here in the Pacific Northwest. If we go backwards, there's this cold front up here. So if you lived in Vancouver, Seattle, and you see this cold front here on Wednesday, you can predict that on Thursday, that cold front would have moved further south. And so we can see here the prediction. And again, this is just a prediction of the weather on from Thursday to Friday, is that same cold front has now moved a little bit further to the south. And then the next map is Friday. So the next map would be the prediction for Friday. You can see that a lot of the severe weather is reduced quite a bit. Texas is pretty much in the clear. We've got, again, cold, warm air from the Gulf of Mexico trying to move north. We still have this cold front here moving to the east. The cold front over here in the Pacific Northwest has met some warm air, and so this is a stationary front now. But you can see how going between these 3 days, starting again with Wednesday, Thursday, and Friday, you can see how these fronts have moved from one place to another. And so it's important as a person that is looking for the future, like if you wanted to go to the beach or if you wanted to do something over the weekend outside, that you be able to look at a map like this and be able to say, oh, well, there's a cold front coming or there's a warm front coming, and be able to predict what the weather is going to be. Okay. All right. So this is a sample question that you would see has been on a past STAR test, but we wanted to talk about it today as some kind of practice as to literally what you would need to be able to do on the STAR test. And you can see we have a weather map here, and we always suggest that you look at a diagram and try to get as much information from the diagram first before you read the question. So if we're looking at this diagram carefully, we can see that there's a cold front here. So the air behind the cold front would be cooler. So 22 degrees Celsius, 24 degrees Celsius. You can see that the weather in front of the front is warmer, 31 degrees Celsius, 34 down here in Houston. We see a warm front right here moving north. Okay, we can see some rain here, rain here, rain here. But the majority of the country is bathed in sunlight. We've got high pressure over in this area, low pressure, high pressure, high pressure. So that would be the first thing you would do, just analyze the diagram. You know that these arrows point in the direction that this cold front is moving. So you would say that in the next day, this cold front will move further to the south. So let's read the question. It says, based on the weather map, which city will most likely experience decreasing temperatures during the next 24 hours? So All right. Well, you know that this is a warm front. So in 24 hours, it will probably be past Atlanta. So Atlanta is going to get warmer, increasing temperatures, but they're asking for decreasing temperatures. So where is this cold front? Where do you predict the cold front will be on the next day? And since again, the arrows are pointing in the direction that the front moves, you would predict that in the next day or two that Minneapolis would get colder. St. Louis could get colder. Detroit would get colder. Minneapolis before St. Louis, and then St. Louis before Detroit. So now we're looking for an answer that would say that either Minneapolis, St. Louis, or Detroit is going to get colder. So if we look down here in the answer choices, we have Denver. Okay, Denver's already inside the cold air. It's behind the front. Minneapolis, because a cold front is approaching. That is true. This cold front is approaching Minneapolis. Atlanta, because a warm front is approaching. While that is true, that because it's a warm front, it's not going to cause Atlanta's temperatures to decrease. It would cause Atlanta's temperatures to increase. And then it says Houston because it's in a high pressure area. Well, there's no real fronts that are approaching Houston right now. So we couldn't really make that prediction. So your best answer choice here would be B, Minneapolis, because the cold front is approaching Minneapolis. Okay. All right, guys. So a couple other examples of some questions predicting the weather in Houston and Orlando for the next couple of days. You could say that, Houston's probably going to be raining because this is a stationary front right here. So Orlando, Houston, because of this stationary front, it's probably going to be rainy for a couple of days because, again, the front is stationary. It's not moving. The weather in Chicago today compared to yesterday. So because Chicago is behind the warm front, you would say today it is warmer in Chicago. Yesterday, this warm front was probably south of it. So you would basically describe Chicago's weather yesterday being cooler, today being warmer. And then what kind of weather is Seattle having? Typically, again, like we talked about on Tuesday, when we see the high pressure, we're typically looking at clear skies and no rain. Another example, what are the current weather conditions in Denver? You can see these indicate that there's snow in Denver. A cold front has just come through Denver, probably creating the conditions necessary for the snow. What are the current weather conditions in New York City? So again, there's the high pressure in and around New York City. So we would consider that the weather in New York City is probably pretty clear and pleasant. And then it says here, what will you expect to happen to the weather conditions in Houston and Chicago in the next 1 to 2 days? So again, this is a cold front. It's moving in this direction. So you would expect the temperature in Chicago and Houston in the next 1 to 2 days would get colder because of that cold front. Okay. All right. So hopefully this kind of gives you an idea of some of the questions that they may be asking you as we move forward on the STAR test. And again, as always, if you have any other questions, just let me know. All right, guys.